Okay, this is Mr. Burgess. We're going to move on with more laws of exponents. Today we're going to talk about the product of powers property, which is pretty straightforward and pretty easy once you see it. But if you've seen some of these problems before today, they might have looked pretty difficult and intimidating. So these are called the laws of exponents, and this is just a couple of them that we're going to see today. So the first law is the product of powers. So that just means that if I have a couple of numbers or a couple of exponents that I want to multiply together, or numbers that are written as an exponent, if they have the same base like you see here, like a to the m times a to the n, then all we have to do to actually simplify that process is just add the exponents together. So let's see what an example would look like. If I had x to the third times x to the fifth, then my final answer would be x to the 3 plus 5, which really simplifies to be x to the 8th power. So if you think about it, that's pretty straightforward, pretty easy. And if we knew what x was, what number it was, we could actually evaluate that and come up with a numerical answer. Okay, let's try a couple more, like 2 to the 4th times 2 to the 5th. Well, if we're just going to add the exponents, that's going to give us 2 to the 9th power. Negative 5, now we've got to remember, if I have a number by itself, then there is going to be an exponent of 1 on it. So negative 5 to the 1st and negative 5 to the 6th would be negative 5 to the 7th power, because I'm just doing 1 plus 6. On this last one, I'm just going to write that down also, x to the 3 plus 7, just to reiterate what's going on here. I'm just adding the exponents. So that's going to equal x to the 10th power. I don't know about you, but I'm thinking that's looking pretty good. All right, let's keep going. There's a few more example problems, so if we just go through those really quick. 2 to the 7th, 7 to the 12th. See how fast you can do these once you know how. 1/2 to the 2 plus 5, which would be 1/2 to the 7th power, and we got to remember the parentheses. This next one would be negative 3/5, and then 3 plus 3 would give me 6. And then x to the 5th times x to the 11th would be x to the 5 plus 11, which is 16. And then y to the 3rd times y to the 1st, that's going to give me an answer of y to the 4th. So I like this property, or this rule of, or law of exponents. It's quite a good one. Okay, there's one more that's similar to it. What if I have an actual exponent, but I put parentheses around it and I raise it to another exponent? That looks kind of complicated, but that's also pretty easy when you get right down to it. All you have to do is, in this case, is multiply these two exponents together. So you'd end up with a to the m times n. So what does that look like with a little more practical example? So then I'm going to just have x to the 3 times 5, which equals x to the 15th power. So keep in mind, this only works if you've got an exponent that you're raising to another exponent. And that's this particular property. So let's try a few. 4 to the 4th to the 3rd power, that would just be 3 times 4, which would be 4 to the 12th power. 4 times 2 would be 8, so that would be y to the 8th power. 2 times 3 is 6, so I'd have negative 4 in parentheses in this case to the 6th power. So these aren't looking too bad either, are they? All right, now here's something that might start looking a little more complicated, but it's still not that complicated. What if I'm multiplying more than one number together over here, and then I'm raising that whole thing to a power? Well, what you would end up doing is you would multiply this exponent out here by any exponents that are on the inside. So in this first one, keep in mind, if you have just a variable or a number by itself, they have an exponent of 1. So m times 1 is m, and m times 1 is m. So I would have a to the m and b to the m in this first example. This next one might look a little more practical. So I've got 2 to the first, x to the fourth, y to the fifth. So I go 3 times 1 is 3. So I will have 2 to the third here. 3 times 4 is 12. So x to the 12th power. 3 times 5 is 15. So y to the 15th power. And then on Alex, if you have a number that's to a power, Alex almost always wants you to simplify that. So that would just equal 8. And then our x to the 12th, y to the 15th. So even though these are a little bit more complicated, they're still not too bad. Okay, let's practice a couple here. So remember there's a 1 on all of these, so 3 times 1 is 3. So we're going to have 2 to the third, x to the third, and 2 to the third now I already know is 8. So 8x to the third, and then 2 times all of those ones, I'd get 3 to the second, x to the second, y to the second. 3 times 3 is 9. 9x to the second, y to the second will be my final answer there. Okay, let's keep her going. And we're up to the number 4 right now. So take a look at this particular one. We've got negative 5x to the fourth times x to the negative x to the fourth. So when we go inside the parentheses and see that negative x to the fourth, we got to keep in mind that there's a 1 on there. So what we want to do is kind of combine the stuff that's alike, because we're multiplying all of this together, and multiplication is commutative, meaning you can rearrange the order in which everything appears if it's going to help you out in solving the problem. So I put the integers together, and now I'm putting the exponents together, still multiplying all 4 things. So negative 5 times negative 1 is 5, and x to the fourth times x to the fourth would be x to the 8th power. All right, on this next one, this rearranging process, sometimes we just say, let's just sort them. So if I use the word sort, that just means rearrange it so that the numbers are together and the exponents are together. And once you get the hang of this, you guys are going to go really fast today. 6 times 2 is 12, and 3 plus 5 is 8, so this will be n to the 8th power. All right, so a couple more problems. Let's try a couple of examples here. So we got negative 1 times negative 5, so I'm just going to kind of, rather than sort them this time, I'm just going to go ahead and write them down. So negative 1 times negative 5 would be 5. And v to the fourth times v to the fourth would be v to the 8th. Negative 6 times 3 would be negative 18. And w to the 5th times w to the 1st would be w to the 6th power. All right, now this, I've got a negative w to the 6th out front. I got to remember my 1 there. So negative 1 times negative 7 would be 7. And w to the 6th times w to the 6th would be w to the 12th power. All right, this next one, negative 3 times 6 would be negative 18. And then we've got to remember there's a 1 on that y there. So y to the 4th times y to the 1st would be y to the 4 plus 1, which is 5. And there's the 4th problem there. Okay, so basically what we did is we identified the numbers that were missing, and then we sorted them so that we could do the things that are alike together, and we finished off the problem. So that's the process. Now these last couple are a little bit longer, so we're going to do the same thing. So we're going to sort the problems, and if we have to, put a little exponent on like on this y that maybe doesn't have one, but put that y to the first one there. So I got 5 times 2 times 4, and y to the first times y to the 8th, w to the 5th times w to the 5th. Down on the second one, I've got 3 times 2 times 4. I've got x to the 8th and x to the 1st right there. And y to the 7th, y to the 2nd, and y to the 1st. Now I can combine everything together and simplify it. So I end up with 40 y to the 9th, w to the 10th on the first one, and 24x to the 9th, y to the 10th on the second one. So those are the kind of problems, and that'll be the most complicated one that you will see today. So on Alex, this is number 55, Exponents Product Property. Good luck, and make sure you submit a screenshot of your score.